In this video, we'll explore how to transfer a function circuit schematic into a PCB layout using Altium Designer. We are working on a simple LED chaser circuit utilizing a 555 timer and a simple decade counter. Here is Proteus software, and we have done our simulation here. By adjusting the potentiometer, we can change the blinking speed of the LEDs. That's it. And here's the schematic in Altium Designer using ICs and LEDs. And finally, here is our PCB with our logo on it. This is the 2D view of our circuit, and this is the 3D view of our circuit. This is what we are going to design. So let's dive in. Here is the schematic of a LED chaser circuit. We've used a 9-volt battery to power the circuit and ICs and other electronic components. 555 timer is a key part of this schematic. We've used C2 capacitor to filter out any noise and connected it to control voltage pin of the timer. The threshold and trigger pins are connected to discharge node, while the discharge pin itself is connected between a 50 kΩ potentiometer and a 10 microfarad capacitor. More RC value means more delay. Less RC value, less delay. You can see the effect of increasing the resistance of potentiometer in the delay of LEDs blinking, and by decreasing the potentiometer resistance value, you see the delay is so much shorter than the previous delay. The output of the timer is connected to clock of the counter. The enable pin of the counter is active low, so it is connected to ground. The master reset pin of the counter is also grounded. The carryout pin of the counter is for cascading it with other counters, which is not the case in this simple project. And the output data is connected to anode of different LEDs, and the cathode of LEDs are connected to a 220 ohm resistor for controlling the current. Launch Altium Designer. Head to the file, New and Project, and choose a name for the project. I'm going to call it LED Chaser, and select a location to save your project. I'm going to save it in a folder called LED Chaser as well. And make sure the name is what you've chosen, and create. Our project is created. Right click on the project, add new to project, schematic. This is where you can draw your schematics in Altium Designer. Save your project by right clicking on it and then selecting save. Choose a name for the schematic document. I'm going to call it LED Chaser as well. Save it. To zoom in and zoom out, I simply use mouse control wheel. If you want to achieve the same level of comfort, head to the settings, navigate to mouse wheel configuration, and uncheck control in front of zoom main window. Now we need to place components in the schematic. To do that, we can use manufacturer part search tab. If it's not available here and you cannot see it, it is in the panels tab. You can find it there. I want to add pin header for the power supply of the circuit. So let's try it. I want it to have 2 pins in a row. Let's search. These are not the pin header that I want. Let's try connector. Again, these are not what I want. Let's use categories. Go to connectors, and in connectors category type header. Enter. This is exactly what I want. This is produced by Molex, and it has 2 pins, and it has a good 3D body. I want to place it. Right click on it and select place, and place it in the project. By pressing space, you can rotate component when you want to place it in the schematic sheet. Nice. Now we need to place a timer. Search for the timer. Oops. We need to set the categories to all, not just the connectors. NE555. And brilliant. This is SMD and produced by Texas Instruments. I want to place it in my project. Nice. Then we need the counter, which is 4017. We wait until it shows up. It seems there is a problem because it shouldn't take so long. Let's try the other name of the IC, which is 748C4017. Yeah, here it is. These are the counters, but their packaging is deep. I want it to be SMD. Surface mount. And yep, here is SMD and produced by Texas Instruments. Nice. You see, it is SMD. I want to place it. Good. Then we need to find LED. To do that, go to categories, optoelectronics, and search for LED. I'm going to use filters for the package and color. I want it to be surface mount, and I want its color to be red. And these are the available components, and we have 3D bodies. Make sure that you choose a package which is 0805. This is not too small, not too big. I like this package size. And this is good, but it doesn't have 3D body. I want it to have 3D body. Of course, you can create your own footprints with your desired 3D body, but creating footprint is not the topic of this video. We may cover it in our future videos. So I choose one with 3D body just for educational purposes. This one seems good, yes. So I place it. And here you can check its parameters like its package, power dissipation, and etc. Then we need to place resistor. Use filters. (0805) package and place it. Good. Then we need to place the potentiometer. Passive components, and resistors, variable resistors, and potentiometers. These are good potentiometers, but they're deep and through hole. I want it to be surface mount. So I use filters, surface mount, and here it is. These potentiometers are easily found in the market and they are surface mount devices. So I place it somewhere like here. Nice. Save the project. And now we need capacitors. By using filter, and make sure its packaging is 0805. This one is good. I place it. And by selecting 0805 packages, now you are free to choose different capacitors from different producers, and you are sure that those capacitors fit in your project because you've chosen standard packaging. Save the project. Well, our components are selected successfully. Now we need to multiply some of them because we need 10 LEDs, not one, and 2 capacitors. So copy and paste it. 2, Control C, Control V, 4, 8, and 10. Nice. So place the capacitor somewhere like here, and here you can change its comment to say what this component is, what is its package, and what is its value, which is 10 nanofarads, but it's a bit long. I like a short form of names, so I just leave the 10 nanofarads. Nice. Copy it, paste it, and place it somewhere like here. Now we have 2 capacitors. Change its comment to 10 microfarads. Brilliant. Save it. Now we need to do the wiring. To do that, you can use the toolbar and wire, or easily by pressing Ctrl W, you enter the wiring mode. Place a power port. By pressing Tab, you go to the properties of the things that you want to place. Change its name to +9 volts and connect it to the wire. Place GND. This is another power port, a GND port in fact. Nice. It is ready. Connect the VCC of the timer to the power port, which is supplied from pin header. As you can see, these pins that are connected to power ports have the same name as the power ports. It's GND and it has +9 volts. These net names help us a lot when we are routing in PCB. Prepare the ground for the timer. Nice. According to the schematic, potentiometer and this capacitor must be connected together. And this charge pin is connected to this node. I want to choose a name for this node, which is its net name. To do that, you could again use the toolbar or simply place PN, which is a short form of placenet. Tab, and you can select this charge name for this node. By using the buttons, you could customize your net label, how big it is, its font, and etc. And connect threshold pin to this node as well. You see now this wire has the net name of this charge. Trigger must be connected to that node as well. Nice. And it has a net name of this charge as well, so it is connected to that node. Connect control voltage pin to capacitor, and then ground the other pin of capacitor. As you can see, these wires that are between two electronics component doesn't have a user-friendly name. I prefer to choose a name that I can easily understand where this wire is connected to. It helps us a lot in routing in PCB. So I choose a net name for it, like PN, and I want to call it control voltage. This is good, yes. And place it somewhere like here. Nice. Save it. The output of the timer is connected to clock of the counter, and by pressing space you can change the angle of wiring. I want to set a name of Q for this net and wire. Q is a usual name for the outputs, and this is the output of the timer. Prepare power ports for the timer as well, and G and D. By pressing Shift and dragging components, you could duplicate them. Nice. Enable and master reset pin are grounded as well, so we do the wiring. Then we connect the counter to anodes of LEDs. Nice. Now it's time to connect the cathode of LEDs together and create a node. And configure the potentiometer pins according to the schematic. You can change the comment to 50 kilo ohms. Save it. And change the comment of resistor to 220 ohms. You can also change the parameters. Value is not 1 kilo ohm, it is 220. And do the same thing for the capacitors that you've chosen and changed their value. Ten microfarads. Do the same thing for the other capacitor. It is 10 nanofarads, but by default it is 100, so change it. Nice, save. Do the wiring for the resistor and ground the other pin. And choose a net name for the cathode of LEDs. Nice. I guess our schematic is ready. Now it's time to annotate our schematic and uh, give a number to every component of the schematic. To do that, head to the tools, navigate to annotation, annotate schematics. It shows how the components are named. You can change it. Update changes lists, OK, accept changes, validate changes, and finally execute changes. Oops, in messages windows it says that we've got an error. Some of the warnings are ignorable, but errors must be resolved. So let's see what is the error. Oops, I've forgotten to connect this pin to the VCC, and it has says you have a floating pin. So let's do the wiring. And oops, pin 12 of the counter is for cascading it with other counters. It shouldn't be connected to LEDs. So let's edit it. And because this pin is not connected to anywhere, to avoid warnings and errors, we can use generic no ERC. So we say that it is not connected to anywhere. Validate it, then check messages. And brilliant, all errors are gone. We've just got warnings. Let's see what it is. It says no driving source for this pin, and this is because of the pin types of the component. This warning is ignorable, especially in this project. Well, our schematic is ready. And now we need to transfer these components into PCB. First, right-click on the project, add new, and select PCB. And here is our PCB document. Save the project. I would like to call it LED Chaser, and this is the PCB document. Right. Now we're going to transfer these components to that PCB document. To do that, head to the design and navigate to update PCB document. I want to add all components and nets, but I don't want to add the classes. Rules, I want them to be added. Validate changes, and finally execute changes. Nice. As you can see, our components with their 3D body is imported to our PCB document. And before anything, you need to define rules for your project. To do that, head to the design, navigate to rules, and here's a place that you can define rules. For example, clearance and spacing between pads and vias, and routing lines, and your routing width and everything, your track width and etc. But as you can see, the unit here is mil, which is imperial. I don't want to work with this unit, so I'm going to change it. To do that, you can go to properties and go to units and change it to millimeter. And now as you can see, the units are in millimeters. Or you can press U and then V. By pressing UV, you toggle the units. You see? So I keep it to be millimeters. Then go to design rules. The minimum clearance by default is 0.254 millimeters. I want to change it to 2/10 millimeters. And ignore pad-to-pad clearance within a footprint. Then I'm going to set first apply it, and it is saved. Then I'm going to define rules for the width of the tracks. I'm going to set minimum to 2/10 millimeters, the preferred to something around 3/10, and maximum to half of a millimeter. You can add new rules by right clicking, and I'm going to set it for the width of the power tracks. So these tracks can be larger. Select custom query, query builder, and first condition should be belongs to net 9 volts. It's good. Add another condition, belongs to net, and GND net, and change the and to or. So if any track or any part belongs to nets GND or 9 volts, so they are a part of this rule, and this rule are applied to them. Okay, so I'm going to set the width of these tracks a bit larger than the signal tracks. For example, mean to half, preferred to 6/10, and maximum to 1 millimeter. Apply. And of course there are other rules that you can set, but this is enough for now. Right. I want to see a schematic and PCB document simultaneously and at the same time. To do that, right click next to the home page and select a split vertical. Now you can see a schematic and PCB document simultaneously. If you want to find components that are present in the schematic in the PCB document, right click in the schematic document and select cross probe. Then click on it, and you are just viewing the component in the PCB document. Place it. To get rid of this mode, press Shift-C. Now we're going to do the placement. I'm going to find the timer, place it next to the header, it seems to be good. Then I'm going to find the counter. I'm going to place it next to the timer. If we place it in this manner, as you can see, the left hand side pins must be connected to diodes. So it is better to place the right hand side pins close to the timer, so they're connected more easily. So rotate it. Nice. And here's the 3D view of our PCB. Nice. Save it. Then place C2 capacitor. This is C2 capacitor. Place it near the GND As you can see, GND of the header is a bit far from it, so rotate the header. Nice. Save it. Place C1 capacitor somewhere like here. Rotate it. Good. To me, the silk screen texts are a bit large, so I'm going to make all of them a bit smaller. To do that, press Shift F, which helps you to find similar objects, and press on the object that you want. And here's the filter window. I want them all to be on the top overlay layer, and I want them all to be designator. Okay, as you can see, all the designators in the top overlay layer are selected. So go to property and decrease the text height. You see, it got a little bit smaller. Decrease the stroke width as well, better. But still they are a bit large for me, so let's decrease their height again. Now it is better. Nice. Now let's continue placing our and selecting the paths, Altium Designer software shows you where this path must be connected to with the use of lights. As you can see, here I want to connect a GND of the timer to GND pin of the header. There is no straight way to do that. And if there is one, it needs to take a long turn, which is not logical. Here is where we use vias. Vias are things that connect layers together when you're routing. To do that, you can use plus or pressing Ctrl Shift and scroll and do the scroll wheel of the mouse forwards, rotating it forwards. Plus, and it creates a wire for you, or by using Ctrl Shift and mouse scroll wheel. And by pressing G, you can set the grids of your PCB document. Nice. And by pressing Ctrl F, you can flip your board and see behind it of your board. And again, by pressing Ctrl F, you could undo what you've done. GND for the counter. Providing GND for the C1. Let's connect cathodes of LEDs together. By pressing a space, you can change angle of routing. It might be a good idea to set cathode of LEDs outwards of the board. Now all cathodes are connected together. Let's connect these charge pins. As you can see here again, I must use vias and I have to find a way to connect these three pads together. Trying to find a way to connect them. Maybe use vias here and another via at the bottom of the IC. But I prefer not to use via here. use a wire here instead. Of course, you can connect the other discharge pins, but unnecessary routings would be deleted. Now I must to find a way to connect these two pads together. First, let's connect these charge pads together. We've already created wires for this node. Now the routing looks better a little bit. Now let's connect the output of the timer to a counter. As you can see, I can do it without any problem and using wires. Nice. Now let's connect LEDs to the counter. The first one. And then second LED. I'm going to use wires. It's a good practice to place wires near the pads. Do it for all of the LEDs. You could even use wire in places that are not necessary. And it's better to keep wires close to the pads. Make sure not to create angles less than 90 degrees. And the two reaching to the last two LEDs. I must find a way to connect these two paths together, but as you can see, the way is so crowded. And usually it's a good practice not to create circles when you are routing. Of course, it is not important in this simple project, but for more complicated projects, it is important. Nice. We just now need to connect cathodes of LEDs to R2 resistor. Let's complete the wiring. And our circuit looks like this. Let's create plus and negative signs in front of the header so we know how to connect battery to our circuit. Make sure you're setting it on top overlay. Plus next to 9 volts and negative next to ground. Nice. In order to measure the dimensions of our board, head to the reports and navigate to measure distance. It is almost 5 centimeters. Our circuit is almost 5 by 5 centimeters. To make our board look more professional, you need to insert your logo to indicate that this board is designed by you. I am going to insert the logo of our YouTube channel on the board. You could select inverted or non-inverted picture. I prefer non-inverted picture. And I set the quality to the highest degree. And I want to place it somewhere like this. Nice. Now they know you've designed this circuit. Now we want to know that the board that we've designed is compatible with the rules that we specified. To do that, head to the tools and navigate to design rule check. Design rule check. Well, we've got 4 rule violations and we must resolve them. Let's see what they are. It indicates that the distance between silk and our pad is less than 0.254 millimeters. We've got 2 ways. The first way is to consult with your PCB manufacturer, and you must know if they are capable of creating such a PCB. If they are capable of this, so you can change the rules that you specify. Otherwise, you must change the footprint that you've used or create your own footprint for this component. For now, we imagine that our PCB manufacturer is capable of designing such a circuit, so we change the rule. Design rules, and it is in manufacturing tab. Silk to solder mask clearance, as you can see, it is 0.254 millimeters. I'm going to decrease it to 2/10 millimeters. Nice. Let's do the design rules check again. Brilliant. No rule violations. Now our circuit is ready for manufacturing. But before that, I'm going to use polygons in our circuit. You can head to the place and navigate to polygon port, or simply use PG short keys. Select a net, specify the layer, and we've got different polygon shapes. I always use, most of the times I use solid. You can remove small islands and make sure you select pour over all sameness objects. And by space you change the angle of shape, and by shift space you specify whether the angles be sharp or rounded. Right click, the polygon is created. If you change the shape of your polygon, you need to report it. I'm going to create a polygon for the timer as well. You can draw all shapes that you like, for example something like what I'm drawing, even if it is not so professional. It is created. I wanted to get all of the 9-volt roots, so I expand the polygon pore. Now it is better. Of course you can draw a polygon pore for the counter, but as long as it is just one pin, it is not necessary. But I'll show you how to do this just for showing purposes. And here it is. Now do the same thing in the bottom layer for the plus 9 volts net. Now it is created. You can always check the 3D model to make sure how your board look like. Now I want to specify the border of my board for manufacturing purposes. It's a good idea to select keep out layer, select line, and draw the borders of your circuit. Select the lines that you've created the border with. You can manually select them all like what I am doing, or by selecting one and then right clicking on it and selecting 5 similar objects, you can select them all. Then head to design, navigate to board shape, and then select define board shape from selected objects. Nice. Now our board is smaller. Now I'm going to pour G&D grounds all over the board, and somehow about 5 millimeters from edges of the board. 1, 2, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, and do it for all the edges. Right click, select the net, nice. This is how our board looks like right now. This is G&D. Now do the same thing for the bottom layer. Great. Check the 3D view. Brilliant. Now this is how our board looks like right now. As you can see, the U1 text is on a wire. Let's move it to create some distance. Select the text and move it. Now it is better. Nice. Now let's create some holes at the corners of the PCB so you can use screws to secure them if needed. To do that, head to the tool panel and select wire. By going to the properties of these pads, you can select the diameter and the hole size according to your screw, for example M3 or any screw type, and place them at the corners. Great. Let's see the 3D view. Nice. Now let's add the name of our YouTube channel to the board. To do that, head to the place and select string. Go to the properties, Sly Fox with capital letters at first. Make sure you select the top overlay and let's place it. Brilliant. And you can see the quality of the picture on our board. Great. You can send this PCB document to your manufacturer and they can produce your PCB. Many manufacturers accept PCB document and they will consult you how to produce it. But some other PCB manufacturer asks you to create manufacturing files for them and they will tell you what kind of file they accept. To do that, head to the files and select fabrication outputs, and as you can see there are many fabrication outputs and you can choose one. Of course you have to consult your PCB manufacturer and see what they need, but here we're going to show you how to create Gerber files because they are industry standard files. You can set the units and head to the plot layers and select used. So the layers that you've used would have manufacturing files. And for these settings you need to consult your PCB manufacturer, so in this video we leave them as default. And you can see the files are being created. Our Gerber files have been created. Let's save it. And here you can check the generated files for PCB manufacturing. Great. And here's the final view of our board. If you want to send this PCB to another person to work on it, they might not have the libraries and the footprints that you've used in your projects. To make it easier, you need to head to Design and make integrated library. Integrated library will be generated, and you need to send this with your project to that person so they can add this library to their project and use your footprints and libraries that you've used in this project. How they can use it, they need to head to components after adding this library to their project and select the library, the integrated library. And as you can see, all the components have been added to the library. For example, here is the counter, or the red LED, the resistor, potentiometer, and other components. If you enjoyed watching this video, don't forget to like and subscribe. Good luck.
Good luck.